Welcome friends. In previous lecture of strength of material, we have discussed the basics and formulas of stress, strain. After that, we have seen the stress strain curve, that is engineering stress strain curve. Now, we are going to discuss the SFD and BMD, that means shear force diagram and bending moment diagram. It is done with three basic steps, from which only first step we are going to discuss in today's lecture, because what happens, students generally make confusion and mixing of those three steps. So we will discuss only first step, that is the use of engineering mechanics formulas and sign convention. For that, we will discuss what is beam, then the types of supports. Here you can see in the slide what are the types of supports, and one by one all these three steps, first, second, and third. Out of this, creating a clockwise momentum due to its self-weight, then there should be an anti-clockwise moment to counterbalance it. That means to keep the member in fixed position or in a standstill position. Otherwise, we can see the design of the component can fail. This is a hinge support, or also called a spin. Even sometimes a small circle is shown here, or you can denote it like this also. It does not create a bending moment, just only horizontal reaction and vertical reaction is created by this hinge joint or hinge support. This is a roller support or slider, you can also call it. It creates only a vertical or a transverse reaction force to the component or a member. If the roller is in this position, then again it will create a transverse reaction force like this. That means perpendicular to the member. Now this is a smooth surface denoted by like this symbol, and it will also create a reaction perpendicular to this surface. Okay. Now the types of beam, different types of beam. First one is cantilever. Here you can see it is a fixed support. Even you can show such hatching lines here also. Then second one is simply support beam. You can see that here both the joints are supports are hinge supports. In previous one was roller and another was hinge support. Even though it is also called as a simply supported, no matter both the supports are hinge support or both the supports are roller support, or either any support is roller and another is hinge. That means if here is a hinge instead of this roller, then even we can call it as a simply supported beam. Got it? Moving to the third beam, that is overhanging beam. Here also there can be either a roller or hinge support. One should be in a continuous direction. Just instead of at the end, supports at the ends only, the end is one support is at end and another is not at the end. So this portion is overhanging. That's why it is called as overhanging. It is actually a single overhanging beam. It can be in a overhanging position from both the sides also. That means here you can see like this way. Here is a one overhanging portion and here another. That means this is a double overhanging beam. In the first type of single overhanging beam, there can be multiple supports, not only that one at the end and another somewhere in between. Here can be many number of supports, even though we can call it as a single overhanging beam. Next one is continuous beam. Fixed beam. Before fixed beam, we will discuss continuous beam because these are related. There may be a confusion. Here you can see there are also supports at both the ends, and few supports are also given in the middle. Similarly, you can see at your home the beams can be supported at different columns, or you can imagine or see at any construction site. No matter only 3 or 4 supports are given, they can be many number of supports can be given to this continuous beam. Then only it can be called as continuous, and there is no overhanging portion like this. You can see here. Actually, this is exactly at the end. This end supports are compulsory, and at least one support in between, anywhere. Not it is not necessary that it should be at the middle only, exactly middle, anywhere. Yeah, fixed beam was remaining. This is the fixed beam. That means on the both sides, both the ends, there is a fixed support. It is very simple to understand. We have discussed both these slides. Now we will start with the SFD. For that, we should understand the sign convention and rules of engineering mechanics, which are used to find the reaction forces. So anytime whenever you start solving SFD BMD problems, forget that we have to find SFD BMD and their rules. Here are different rules that is from the engineering mechanics subject and its own conventions, which will not be used once we find the reaction forces. And why we are finding the reaction forces? Because these forces are necessary for drawing the shear force diagram and bending moment diagram. So always keep in mind this note: once forces due to reaction are derived by rules and conventions of engineering mechanics, they never use these engineering mechanics conventions again in further step number 2 and 3, which are used for finding SFD and BMD, to avoid confusion and mixing. That means don't mix these rules with second step or with third step. In every step, that means if I am talking about step 1, there is only one rule or one subject we will discuss for the rules and convention. So let us start with the step number 1, that is finding reaction forces. How we will find the reaction forces? Find all the reactions on beam by using the rules of engineering mechanics. That means, for example, summation of all forces in one direction. Let us say summation x. Here you can see summation f of x. That means forces in x direction or in the direction of x-axis will be equal to 0. Similarly, put all this formula. Generally, we will have to use this fx and fy in case of B. Fx equal to summation of fx equal to 0, summation of fy equal to 0, and next equation or method is step is, that means we are talking only about the step 1, finding the forces. For finding, we also need to derive these bending moments. The moments at particular point. It is not related to BMD, bending moment diagram. Only we are first finding these forces, which are reaction forces, which are generated due to either by self weight or by UDL, UVL. That means any type of force or even a external applied moment. What will be the forces and the force moments generated due to these reaction forces or external applied forces? We will find by these two equations of methods of equilibrium of engineering mechanics. That is summation of moments, all moments at a particular point. Let us say point A, which is at the end, any of the end or the any support, either on the left side or right side. We will put this better. I will explain in the diagram example here. And for finding these forces, which formulas or conventions we have used, we will evaluate the summation of moment at point either A or at point B. Let us go with summation of moment at point B. What we do for finding moment, we multiply the force into the distance from the point from where we are calculating the summation of moments, or the for which point or at which point we are calculating the summation of forces and summation of moments. The sign convention for that is written here. Clockwise moment is always taken as negative. I repeat, clockwise moment is taken as negative and anti-clockwise is taken as positive. Okay, don't confuse with this second step. This is totally different. Here we can find the summation of moments at point B by multiplying this force. Let us say P force is equal to 10 into this distance B. Okay. It is in the negative, anti-clockwise direction. That means you know that anti-clockwise direction, the moment will be positive. Here we have taken 10 into B. Or going from this side, first we will calculate moment due to this reaction RA. Excuse me. RA into this complete distance L. RA into L. And as this is creating a clockwise moment here like this. R is forcing the member in the upward direction. That's why if we consider we are considering moment at point B, that means with respect to point B, reaction RA is creating a clockwise moment. So clockwise will be negative. So multiplying RA with the distance between the point of consideration and the point of action of a force or the reactive force. This will be minus RA into L and plus, because this is a positive anti-clockwise. So as per our convention, it is a positive moment. So plus 10 into the distance from the considered point equal to 0. This is nothing but the expansion of the summation M at point B, summation of moment at point B equal to 0. Once we transfer this to the RHS, we will get reaction force RA in terms of B and L. B and L are nothing but the distances which will be given. So we can find out the RA. Similarly, we can find RB by considering the summation of moment at point B equal to 0. This is only about the finding reaction forces. It do not consider or confuse with shear forces. We will discuss shear force diagram and finding shear forces and BMD in next lecture. Just look at the 3 steps only. First step we have discussed. In this, we have taken clockwise moment negative and anti-clockwise moment positive. This is all about the finding the reaction forces. Now, second step is the finding out the hogging and sagging for the shear force. That means finding out shear force equations and bending moment by using sign convention for shear force and bending moment. Here we are going to use different notations or sign convention which are shown here. Here, first look at the diagram in the bottom. These 2 diagrams. You can see this curve is known as hogging. Hog means the upper side of a pig, the curve of a upper side of a pig, and from that this word is derived, hogging. Now you can remember by this diagram. You can see this is a negative attitude in this emoji. That's it. We take always hogging as negative. That means moment created by hogging will be negative, whether it is clockwise or anti-clockwise. It doesn't matter. Both the moments will be negative in terms of hogging, and exactly opposite will be the sagging. If the applied forces is creating bending like this, it is called as the member is associated with sagging moment, and that will be positive. Both the moments will be positive. Okay. Actually, it does not have any relation with the reaction forces which we have find out in this step 1. So better you forget this second step as of now, and third step also. In which third step we are going to use the mathematical graph theory and curve fitting for drawing the SFD BMD. So in today's lecture, I wind up with this step 1 only, and I have already discussed this example with you. Just here are few see these few examples. What is the reaction force diagram, that is force diagram, shear force diagram, and bending moment diagram. In first step, just we have find out these reaction forces. Here you can see these are different types of loading. UDL means uniformly distributed load. It is because of the self load of a member or a component or a beam. Okay, here it is a uniformly varying load, UDL. Then their associated shear forces and the diagrams along with the bending moment diagrams. This from these slopes we will draw this diagram, and that we'll see in next lecture. Just for your information, for why we have calculated or evaluated these reaction forces, because these are required in finding shear force diagram and BMD. So thank you.